Welcome everybody to our webinar today. My name's Alex McCutcheon. I'm a director of Unicom. We're hosting the presentation today. Today's theme is common system and software testing pitfalls. And I'm particularly delighted to welcome our presenter, Donald Firesmith. Donald is principal engineer in the Software and Solutions Division of the Software Engineering Institute based in Pittsburgh, US. He works closely with the US military and other governmental agencies acquiring large and complex software-reliant systems. Don's got many years experience in this space, in software testing and quality, and I know from personal experience, having seen his presentation in Chicago, you're really going to enjoy today's talk. I also just wanted to point out that Donald's coming to London next month. He's actually delivering a workshop, a full-day workshop in London on 24th of June, entitled Common System and Software Testing Pitfalls, the same theme as today's presentation. So the webinar today is also a really good taster for the full-day workshop. Also following the workshop, on the 25th of June, we have a major conference taking place, the 12th Next Generation Testing Conference. And the theme this year is new models and methods for meeting today's challenges, which Donald is also speaking at and sharing. There will be details available on our website at unicom.co.uk. Also, just to point out a bit of housekeeping for today's webinar, that at the end we will have an opportunity for question and answers. So please feel free to type your questions in, and Donald will aim to answer as many as possible at the end of the presentation. So without further ado, I will hand over to Donald.
Okay, thank you very much. I'm going to go through here the topics that we're going to try to cover today. This is really a large topic, and I've got 45 minutes. So the purpose here is just to give you a but software-reliant systems that we're talking about here. I'm going to give you a taxonomy of different kinds of pitfalls, of testing blunders, testing mistakes, and an ontology that sort of defines the terminology of these pitfalls. And I'm going to talk about how using these pitfalls can help address the testing challenges and the goals and potential uses of the material I'm going to be covering today, and for that matter on the 24th of next month. I'll give one complete example just so that you can see the kind of information that is given for each of the pitfalls, and then I'll move right into the actual repository of testing pitfalls, which fall into two basic categories. There's general pitfalls, and then there are pitfalls that are specific to a specific type of testing, like unit testing, integration testing, user testing, and so on. And then we'll follow up with a very brief look at the limitations of this work and some questions that are still open that we're doing research on right now. And we'll look at some of that future work there. So let's move into testing. I'm really referring here to traditional testing, not all of quality control, but the actual testing where you take some kind of object under test, whether it's software, a system, or for that matter, an executable model like a requirements model or an architecture model, and you put that object under test into a specific pre-test state. You set up some preconditions, and then you give it some specific stimuli, whether those are commands or data inputs, trigger events like a certain time taking place, and then you compare how it behaves with how you expect it to behave. So we're really talking about the execution of something and seeing whether it behaves the way you expect it to behave under certain circumstances. As I mentioned before, the thing that we're testing, typically it's a software application, a component, or a unit, but in the work that I deal with on very large, complex systems, primarily for the U.S. government the last 15 years, we're talking about things like aircraft or ships or telecommunications systems, things where you actually have hardware and software, sensors, actuators, things of that nature. And the really interesting one now is we're moving testing, shifting it left so that it's not just testing the software and the system earlier in the life cycle. We're also shifting testing left to the point where we can now use executable requirements models, architecture design models, and test them before we even have any software to test. And therefore, this, really requires the execution of the object under test. So I'm not really talking about analysis, demonstration, inspection, all of the other types of quality control methods, just specifically testing here. And that requires that I am able to control this, the object under test and also observe how it behaves. So controllability and observability are the two things that make testing possible. Why do I test? There's lots of reasons. The main one is to uncover significant defects in the thing that I'm testing so that they can get fixed. But that's not the only reason. One of the things we want to do when we test is to collect evidence that helps us determine the quality of the thing that we're testing, how fit it is for the purpose we intend to use it for, and whether or not it's ready to ship, deploy, to be placed into operation. Another reason why we test is as a type of process improvement. Testing helps us identify mistakes, defects, rather, and then we're looking at our process that introduced those defects, whether those are developmental processes that put the defects in or testing processes that fail to uncover the defects, because regardless of what kind of testing we do, it's never 100% perfect when it comes to picking up defects. And lastly, we often do testing these days to prevent defects in the first place. One way of doing this is testing the models before we get the code, taking the bugs out of the models, and therefore we're taking the bugs out of the resulting code. And if we use something like test-driven development to develop our test cases, then the mere activity of developing the test cases helps us do the design and the implementation with fewer defects. What are the limitations of testing? First and foremost, there's no way to completely test anything non-trivial. The systems we have essentially have, for all practical purposes, an infinite number of paths through them, an infinite number of inputs we can give, and an infinite number of orders. And so, consequently, every test case we use only looks at one behavior of the system under one circumstance. We can't uncover all the defects with testing. One of the reasons is that different types of testings have different efficiencies when it comes to spotting the defects, and it also uncovers different kinds of defects. What this means is no single type of testing basically does it all, that you have to use multiple types of testing. Another problem with testing is you could end up with false positive and false negative test results. What that means is we can't prove that the object under test works properly under all circumstances. Okay, what are the challenges we're facing? First and foremost, there's an awful lot of ways people have found to screw up testing. When I talk about commonly occurring testing pitfalls, I mean pitfalls that people have fallen into over and over again on various programs. Another issue is I have never seen a single program, a single project in which people, not only avoided all pitfalls, I've never seen one where they haven't fallen into multiple pitfalls. one of the reasons why I started this work of collecting pitfalls is I got very tired of seeing the same mistakes being made over and over and over again. Now, at least different programs tend to exhibit different types of testing pitfalls, which will mean that the pitfalls I'm discussing today aren't necessarily relevant to all projects. And then the other thing is there are an incredible number of very good testing books out there. These testing books basically tell you how to test well. The problem is, in spite of these testing books, in spite of the wonderful talks at conferences and so on, people keep making the same mistakes over and over again. And that's why I decided to concentrate not on a how-to book, but if you will, a how not to test book. Okay, let's take a look at the testing pitfalls themselves. What are they? They're basically human mistakes. They're mistakes, blunders that we make that unnecessarily and unexpectedly cause our testing to be less effective at uncovering defects, less efficient in terms of the time and effort that we expend trying to uncover those defects, and frankly, more frustrating to perform. So a testing pitfall could be a bad decision that you make, could be an incorrect mindset that you have, it could be a wrong action that you take, or it could be a failure to act in the first place. Now, this failure could be a failure to adequately meet a testing challenge or to address a testing problem. So these pitfalls are not challenges. These pitfalls are not testing problems. They're basically failures to properly address and handle those challenges and meet those problems. Colloquially, testing pitfalls are just ways of screwing up testing. And if it's common testing pitfall, that means that we've seen it several times on different projects, and it happens often enough, and the negative consequences are severe enough that that makes it a significant risk to our program. As I said before, these pitfalls apply not just to software, but also system testing, and for that matter, executable models. And most of the pitfalls I'm going to mention today apply to both software and systems. And that's actually good because even if you're a software tester, odds are that you're testing a system that where the functionality, the capabilities are almost totally in the software, but nonetheless the software must execute on some hardware, and there's often other software running on that hardware, and there's the software's communicating over various networks, and the software has to meet certain quality characteristics, quality requirements, theilities, things like capacity, performance, reliability, maintainability, safety, security, usability, and so on. And all of those quality requirements are really truly at the system level rather than the software level. So let's talk about what we're going to do to deal with this. We're going to talk about a testing pitfall taxonomy, which is a hierarchical classification of these testing pitfalls into categories and subcategories. We've identified basically to date over 160 different pitfalls, and that's just too many pitfalls to have in one big long list. So they've been basically grouped into categories and subcategories so that it's easier to find the pitfalls that are relevant to you. We're also going to be talking briefly about an ontology, which is nothing more or less than the concepts that, and their definitions that refer to these testing pitfalls. This is the one picture of our ontology that basically describes what I'm talking about today. What we've developed, if you start at the upper left-hand side, we've developed a repository of testing pitfalls. You can think of that as an anti-pattern language in testing anti-patterns. And it's been categorized into these testing pitfalls, and some of them are general pitfalls and others are specific to specific types of testing. And there are many subcategories under each one of those. Now, the individual testing pitfalls themselves, if you look in the upper right-hand side, each one of these pitfalls has been given a unique identifier, a title, a description. We talk about the potential applicability. Not all pitfalls are applicable under all circumstances. The characteristic symptoms that you might notice to see whether or not you're about to fall into the pitfall or that you've already fallen into it. The potential negative consequences that result from having fallen into the pitfall. The causes that might have caused you to fall into the pitfall, and various recommendations, specifically recommendations to prepare for dealing with the problems, enabling you to actually avoid the pitfalls, to recommendations for how to do things to perform the appropriate activity without falling into the pitfall, and verification recommendations to see whether or not you're dealing with the pitfalls properly. And then every pitfall has related pitfalls. Okay, so as I said before, we got this anti-pattern language of how not to do testing. And this pattern language is documented in this book by Addison Wesley that came out January 1st of last year. And if you come to the conference, one of the side benefits is you will get a 35% conference discount on that book. Now, that book covered 92 different pitfalls classified into 14 different categories. And one of the nice things about this collection of pitfalls is it was very heavily reviewed by 47 different international testing subject matter experts. Of course, time doesn't stand still, and right now our pitfall contains 170. Our pitfall repository contains 176 pitfalls, classified into 24 categories. Now, there's going to be a second edition of the book that's eventually going to cover all of these new pitfalls, but in the meantime, the publisher has allowed me to document these new pitfalls on my website, the address you can see right there. And so if you want to know what the pitfalls are, if you look at the original book, that'll give you 92 of them, and then the remaining ones will be on my website. And I am looking at possibly making a testing pitfalls wiki down the road, but that's not happening right now. Oh, I will point out that on my personal website where the new pitfalls are, the contents there are draft. Unlike the book, they have not yet gone through heavy review. So you can expect those to be incomplete, some of them, and also subject to change. What am I doing with a pitfall repository? Well, first of all, I hope that it becomes sort of the de facto industry standard taxonomy for describing testing pitfalls. There's none out there that are at all like it. There are quite a few papers that say the top 5, 10, 25 different pitfalls or mistakes, but this is really the only relatively complete repository of pitfalls. I'm hoping thereby to reduce the incidence of these pitfalls occurring and thereby make testing more effective and efficient, and thereby hopefully increasing the quality of the objects under test. People are using these pitfall repository, the book, as training materials for standard terminology of testing pitfalls. A big thing that people use this for in the U.S. Federal Aviation Administration has also been using this quite a bit. They're using these pitfalls to generate checklists, producing test strategies, evaluating proposals, evaluating the test strategies and plans, evaluating the as-performed test process and the work products, identifying test-related risks. And one of the things that I'm working on now is to produce a relatively simplistic AI tool that's going to basically provide advice on pitfalls. It's hard to deal with 176 different pitfalls. I'm hoping that the tool will be able to elicit some information about your project and give you then advice about which pitfalls are most likely to be relevant to you. And we also use the pitfalls for collecting metrics. Now, I don't have time to go through all the pitfalls, but I want to at least show you what one of these pitfalls looks like when it's completely documented. So here's an example: testing engineering processes not being integrated together. And it's given a one-sentence description. It's given some information about its potential applicability. Then there will come a list of characteristic symptoms. If you see these symptoms, it does if you fall into the pitfall. The middle one deals with schedule. Here, the more black, the more this tends to put you behind schedule if you fall into these pitfalls. And then the last one is more or less project of morale, how it affects people's, how they feel about their job and the frustration that they deal with. And once again, there will be a list of negative consequences. Notice, once again, these are potential negative consequences. Just because you fall into a pitfall doesn't necessarily mean that you're going to fall into all of these, suffer all of these consequences, but they are definitely possible. Each pitfall will have various potential causes. They get listed next. And then when it comes to recommendations, you'll see that there will be a bunch of recommendations for preparing to address the pitfall, enabling people to deal with the pitfall, things that you actually do to avoid the pitfall itself and work your way out of it if you fall into it, and verification techniques that can be used to determine whether you're on track. I mentioned that these pitfalls form an anti-pattern language. As in any pattern language, there are relationships between the patterns in the pattern language, and so every one of these pitfalls will have a bunch of other pitfalls associated with it, and that's what this list is all about. Okay, let's talk now about the different kinds of pitfalls. The first general category are pitfalls that are not specific to any one specific type of testing. So some of the pitfalls are related to test planning and scheduling. Some of them deal with how well the stakeholders are involved or not involved with the testing program and their commitment to support that testing program. There's a fair number of pitfalls related to project and test program management. In other words, these are mistakes that managers make that cause problems. There are staffing related pitfalls, largely having to do with testers and people's experience and expertise levels and so on. There's the testing process itself. This is the largest group of pitfalls. There's more pitfalls in this group than any other. Next one is test design. Here's where we're talking about pitfalls related to selecting test cases and determining whether or not you've done a complete job of testing or a complete enough job of testing. And those are all in the original book. We also have some new categories since the book. Some of them are related to just how one uses or misuses this repository of pitfalls itself. There are test tools and environments mistakes you can make with regard to those. There are mistakes one can make when automating testing, mistakes made when communicating amongst each other, either verbally or via documentation. Dealing with testing as a service, that's a popular topic these days, and you can make various important mistakes when you're actually hiring someone, to provide testing as a service. Mistakes made with regard to the requirements driving testing, and also the creation of test data and how you keep track of it and deal with it. Going into the first category, I do not have time. In fact, I've only got a relatively short amount of time, 15 minutes left, or actually 20 minutes left. So I don't have enough time to go into each one of these, but I will try to touch on at least one representative case for each one of these categories of pitfalls. So in the testing and scheduling one, probably the one that's most common and we have to deal with is inadequate testing schedule. In fact, I've very, very, very rarely seen a project where adequate schedule was devoted to testing. When it comes to stakeholder involvement and commitment, one that's quite popular is unrealistic testing expectations. Often stakeholders believe mistakenly that you can test quality into your system, that if it passes testing, it doesn't have any defects in it, that you can prove that it doesn't have defects with testing, things of that nature. When it comes to management pitfalls, there are a lot of ones here that we see over and over again. Inconvenient test results being ignored is a fairly common one. Very often, late in the program, we will realize that the system is not in good enough shape to ship, that there are definite problems with it that need to be fixed, and sometimes management must decide to go ahead and ship anyway, but often the case is one based on wishful thinking rather than actual evidence. When it comes to staffing, there's issues about who's responsible for doing the testing. This, by the way, has become an interesting case with Agile programs, where there's an impetus to have developers responsible for all of the testing, which can be a real problem because many of the developers do not have adequate training and expertise in testing. There are additional ones here. And now from a process standpoint, as I mentioned before, this is a really huge area of pitfalls. Let's see, what would be a good one? I already mentioned testing and engineering processes not integrated well together. Very often testing is viewed as sort of a specialty engineering area off to the side, and the developers develop their systems, throw it over the wall to the testers, and the testers have to then test it in relative isolation from the developers, from the subject matter experts, from the users, and so on. That's typically a major problem when it comes to having problems with scheduling and getting the right quality software when it comes to testing. As I mentioned before, there are a large number of testing pitfalls here. Notice that many of them are new since the book. When it comes to test design, very often this is a case of relying too much on one type of testing. A good example of this is if you have your developers performing most of the testing, if not all of the testing, rather than professional testers, very often the developers basically are using testing to prove that the system works rather than to show or identify where the system doesn't work. And for that reason, they'll often do an awful lot of sunny day testing, showing that, the system does do as it's supposed to do under, normal circumstances, but that's not where the defects tend to lie. When it comes to pitfall-related pitfalls, these are both new. And the one case that I've seen bank up in Canada trying to get a little overly ambitious when it comes to this and trying to change the testing process to avoid all 100 and some pitfalls simultaneously. No process improvement program can ever really attack that many things simultaneously and be effective at it. When it comes to the test tools and environments, there's all sorts of potential problems here. Probably the biggest one is poor fidelity of the test environments. If the test environments are not like the actual operational or production environments, then you can potentially pass testing and still fail in the field. Automated testing, an extremely popular topic right now, and as you'll see here, there's quite a few different automated testing pitfalls. See, some of these are kind of interesting. Some people try, especially these days, because of the move to Agile, they try to automate everything. And that's really important in some sense, because if you're going to have an iterative, incremental type life cycle with very many small increments, then you're going to have to do a huge amount of regression testing, and that's just not going to happen unless it's automated. So there is that impetus to greatly increase the amount of automated testing. However, there are certain kinds of testing, exploratory testing being one, and usability testing that are basically impossible to automate and are quite effective at finding mistakes the automated tests are not. So trying to go all automated just doesn't make sense. Some more pitfalls on test automation. Test communication. Probably the big one here that you see over and over again is inadequate communication concerning testing. A lot of these pitfalls happen because the people making the mistakes haven't adequately communicated with others on the mistakes. Testing as a service. Here, a big one is a lot of people just don't have outsourcing expertise, and when they try to do testing as a service to outsource their testing, they just don't have adequate oversight and so on of the testers. They don't really have that ability yet to manage outsourced work. A lot of problems with requirements can result in testing problems. Probably the most important one here, the interesting one, is tests as requirements. There's been a trend recently to treat tests as if they were requirements. And unfortunately, that just doesn't tend to work very well. You see this somewhat in the Agile community, and Bertrand Meyer has a great book out on Agile called Agile, the good, the hype, and the ugly. And it talks about the significant difference between requirements, which are more general, and the tests, which verify the requirements but are nowhere near as general as the requirements are. And then when it comes to test data, one of the interesting problems here is people allowing production data to bleed into their test data, or test data to bleed into their production data. Both of those can cause all sorts of problems. Now, let's take a look at test-specific type problems, and I'll go through these faster. We're talking about executable model testing, unit testing, integration testing, specialty engineering testing, system testing, user testing, A/B testing, which is a type of comparison testing between two variants of the system, acceptance testing, operational testing, systems of systems level testing, and regression testing. Because of the time constraints, I'm going to essentially go through these super fast, other than to stop now and then, like in this case. When it comes to specialty engineering testing, most of the time what we're talking about here are quality type tests: safety, reliability, portability, interoperability. These kinds of tests typically require their own testing type and own way of coming up with test data, test cases, and so on, and are often just not adequately done, and often the requirements driving them aren't that good either. Moving on, let's, since we want to have little time for questions and I'm running rapidly out of time, I'm going to go into what's, what's left on this. Okay, current taxonomy. What we've got here is based on experience. The 176 testing pitfalls are based on my experience, based on the experience of a whole load of other people, my current and former colleagues, the 47 different subject matter experts, collections from various conference papers, presentations, articles, and so on. So it's based on experience, but there's not really been any formal study, formal research on it to really identify which of these pitfalls are most important. So what is that? What remains? We don't know for sure. I mean, I could give you my opinion, but it would just be my opinion. We don't know for sure what pitfalls occur most often and how often they do occur. We don't know which pitfalls cause the most harm. We don't know which pitfalls, therefore, have the highest risk. And we don't know what factors, for sure, influence the frequency, harm, and risk of these pitfalls. Basically, depending on your situation, different pitfalls should be relevant. Not all of the same pitfalls are relevant to all the projects. So one of the things I want to do is I want to update the book. Right now, the manuscript for the second edition is current with all these new pitfalls. I am looking for technical reviewers of the book. It's not quite ready yet, but it will be soon. The real thing I want to do, if I can get the funding or if I can get the people interested to volunteer to work with me on this, is I want to do a proper industry survey. I want to find out which pitfalls happen most often, have the worst consequences, have the highest risk, and I basically want to be able to ask questions about the program, about the system, and based on the answers to those questions, then answer the above questions. And that would deal with questions on the input on the system itself, project, the organization, and so on. Oops. So we have all of about 4 or 5 minutes left. This is my contact information. Please feel free to contact me if you have any questions about any of this. I will be more than happy to get back to you afterwards. I hope to see some of you next month in London, where we will spend all day going over these pitfalls. And I guess we'll open it up to questions now.
Thanks, Donald. That's a great webinar. We're just waiting now for any questions coming in. And as Donald mentioned, if you'd like details of the workshop next month and the related next-gen testing conference, they're at unicom.co.uk. We will also, by the way, be making a recording of this webinar available if you'd like to share it with your colleagues. So we'll send you a link very shortly so you can go directly to the recording of this presentation.
By the way, while we're waiting, another thing, the workshop that I'm going to be performing the day before the Next Gen conference is in fact going to be a workshop. It's not going to be an all-day long tutorial. It's actually going to be hands-on discussion where everybody involved is going to be discussing the pitfalls that they've seen on their programs, how they recognize them, what they did about them. We'll be going over all the different kinds of pitfalls that I talked about today. But what I'm hoping is that we actually discover some new pitfalls, that we identify some new information that can be added to the repository, and that we all have an interesting time talking shop and sharing our experiences.